Welcome to my YouTube channel, Manohar Chemistry. You might have seen my thumbnail. The reason for the war between Israel, Iran, and America is chemistry only. Yes, I stand for my statement. This is chemistry only. So far, you might have seen the article related to uranium enrichment in electronic media and print media as well. So that uranium enrichment is completely related to chemistry part. So that's why I given this statement. The reason behind the war is chemistry only. Uranium is a element belongs to chemistry and its atomic number is 92. Mass number is 235. So nearly chemistry in chemistry 118 elements are there exactly. So in that uranium is one of the elements. Uranium atomic number is 92 and uranium has two isotopes. So let me explain what is isotope. Isotope means having same atomic number, mass number is different. So here two different uraniums are given, that is uranium 235 and uranium 238. It is having mass number 235. One uranium having mass number 35 but its atomic number is 92. And one more uranium having mass number 238, atomic number is 92. So having same atomic number, mass number is different. That is called what? Isotope. So in nature, if you are collecting uranium from anywhere, it is a combination of two. That is 92 uranium 238 and 92 uranium 235. So in uranium, these two will be present. So we need uranium 235, uranium 238, not that much helpful. Okay. In this slide, this you will understand. So let me explain one more slide in detail. Now, uranium enrichment is the process of increasing the percentage of a specific type of uranium called uranium enrichment. Means in uranium, I told you just now, uranium 235 will be there as well as uranium 238 is there. Atomic number 92 and 92. In this mixture, so if you are removing 238, then whose percentage will increase? 92 uranium 235 percentage will increase. So this process is called what? Uranium enrichment. Increasing the percentage of uranium 235 in the mixture is known as enrichment of uranium. So why we have to do enrichment, that we are going to discuss now. Why enrichment is needed means, so uranium, in the uranium mixture, uranium 238 will be present in 99.3% and uranium 235 will be 0.7%. But this is not useful for us. So uranium 235 percentage we have to increase. So why we have to increase uranium 235? That uranium 235 only used in nuclear power plants for the preparation of current. So in nuclear weapons, we are not going to discuss in detail about this. This video is only educational purpose. Next point. So what is enrichment means? What enrichment means? Just now I told you, increasing the percentage of uranium 235. During the process of enrichment, you will get two types of uranium. That is low enrichment uranium and high enrichment uranium. Low enrichment uranium means 3 to 5% only. If you purified uranium 3 to 5%, that is called what? Low enrichment uranium. If you go for 90% enrichment, means 90% uranium 235 only you are collecting, that is called what? High enrichment uranium. Okay, this is used in nuclear weapons. So how can they extract actually? So from uranium mixture, how can they separate only uranium 235? What are the steps involved in that? So this is not our part. We are not going to discuss this. So this one we are going to discuss. From the ore, uranium will be collected like this. Uranium ores will be collected and uranium ores will be entered into crusher and they will make it finely powdered ore. Okay. So yellow cake, ore of uranium is this one, U3O8, uranium oxide, that yellow cake. Yellow cake they will extract from the mining, so that they will make it fine powder by using crusher, and they will convert this solid uranium oxide, this is solid in state, that will be converted into gaseous state. How they will convert into gaseous state? By reacting with fluorine. When it reacts with fluorine, it will be converted to uranium hexafluoride. Means they will prepare uranium hexafluoride. In this uranium hexafluoride, two uraniums are present. That is uranium 235 and uranium 238. Two uraniums are present in this. So this gaseous uranium hexafluoride will be taken into gas centrifuge. Gas centrifuge means this continuously rotate. This centrifuge mission will continuously rotate in circular manner. So in this, uranium 235 is there as well as uranium 238 is there. So when it is continuously rotating, uranium 235 will come close to this cylinder, means if rod is there, it is rotating, it will come close. When circle is there, it will be uranium 235 will be come close to nucleus, whereas uranium 238 will present here. So when it is continuously rotating, uranium 238 will come out. Uranium 238 will come out and uranium 235 will remain in the cylinder. Here the doubt will come. Uranium 238 is having more weight and uranium 235 is having less weight. So according to our knowledge, uranium 235 should come out. Why? Because which one is having low weight, that should diffuse very fast, that should move fast. Yes, you are right. Uranium 235 is supposed to come, but uranium 238 only will come. The reason for this one is uranium 238 is having more inertia. Why more inertia? Because inertia will depend on mass. So uranium 238 is having more mass, so more inertia. Again the doubt will come. If it is having more inertia, it's not supposed to come out, no? It should stay in one place only because of inertia. Here the context of inertia is different. So when this centrifuge is revolving in circular manner, uranium 235, 238 is unable to adapt that circular manner. So means it is having inertia to change the direction. So uranium 235 immediately it will be involved in circular manner. So whose inertia is less now? Uranium 235 is less inertia. Means immediately it will start rotation. So that's why it will come close. But uranium 235 not in the mood to revolve in circular manner. So that's why it will kick out. That's why it will come out. So uranium 235 will come out. Then what is uranium 238 will come out. Then what is remain in the solution? What is remain in the centrifuge? Uranium 235 will remain in the centrifuge. Means you are removing 238 outside and you are increasing the intensity of uranium 235. So this process is called uranium enrichment process. Okay. How this uranium enrichment will be used in a preparation of current, now we are going to discuss. So this is nuclear reactor. In this nuclear reactor, first uranium 238 we are taking, uranium 235 we are taking. So here you see, current in nuclear reactor, current production, power production will take place due to nuclear fission. Then what is mean by nuclear fission? So there is a neutron. When neutron is making collision with the 92 uranium 235, then it will be dissociated into fission product, that is barium and krypton, and it will produce 3 neutrons. Again these 3 neutrons will react with remaining uranium. Again this will produce barium and krypton, again 3 neutrons. Continuously energy will release, neutrons will release, huge amount of heat will be released. That huge amount of heat, in step 1 nuclear fission reaction takes place. Due to nuclear fission reaction, huge amount of heat production will take place. In second step, the whatever the heat released here, that heat will be passed through water steam generator. Means here water will be there, so coolant, we can call it as coolant. Water will be there, so coolant means in this, during this process lot of heat will be released, no? That to reduce the heat, coolant will be used. Here we are taking D2O or H2O will be used as a coolant. Water we are taking. Due to this heat, that water will completely boil. So heat production will take place. That heat production will be transferred to coolant. In third step, it will be transferred to coolant, and because of that coolant, absorption of heat, that will become what? Steam. That will become steam. That steam will be passed through water turbines. That steam will be supplied to turbines. So because of this force, because of this steam, these turbines will start rotate. When turbines will start rotate, this is mechanical energy. So mechanical energy will be converted to what? Electrical energy. The turbines will rotate, high pressure steam moves to the turbines, then turbine blades will rotate. The turbines will generate mechanical energy. That mechanical energy will be converted to electrical energy with the help of transformer. So from this transformer, this will be supplied to power grid. So this power, with this power grid, electricity will be supplied. So in this, during this entire process, uranium 235 will be used. If the Iran is using uranium for the production of current, then no problem to the world as well as America, to everyone. There is no problem to anyone. If Iran is using uranium only for the production of current, there is no problem. If Iran is producing this one in another manner, so another manner means it is using for this one for the nuclear weapon purpose, then that is a problem. So if Iran is producing 90% uranium to 235, enrichment process reached to 235, so it may go to wrong path. So that's why, so geopolitical tensions will increase. So that's why war has started. So only I have taken chemistry part. So I hope you liked this video. If you like this video, share, subscribe, and thank you. Have a nice day.